Kia ora, Year 11, part 2 of this. I'm doing subject to the formula again. I just want to go through a few harder examples. The last one, and this is especially tricky, but we'll talk about that soon. I just want to go through a couple of common things. The first is that when you've got something that's going to be squared or cubed or whatever, you need to think carefully about how you're getting rid of it. So here we want y the subject of the formula. So the same as before, you want to get just y to one side. So it's minus a, we've got k minus a equals y squared. Now I want you to think carefully. If something equals a square number, y could have been squared. The only way to make, so if you had a question that looked like this, x squared equals 16. The two numbers that could have made that, well, x could have been 4, but it also could have been minus 4, because minus 4 times minus 4 is 16 as well. So if you want to square root this, and that's what you should do to get rid of a square, square root it, your square root k minus a, that is y, so that's what we did here. The square root of 16 is 4, but you need to accept that there should be a positive and the negative version of this. All right, so we want to go make sure that we include both in our answers. All right, let's have a look at the second one. And what it is a squared plus b squared equals c squared, which most of us know is a Pythagorean density. So we could have b squared equals c squared minus a squared. What we've done there is we've taken away a squared from both sides. And again, if you're square rooting, you need to take plus or minus square root. Now, we've never mentioned this when we're doing Pythagoras, but that's because the lengths of rectangles are always positive. But if you square root something, you want to be thinking, have I got both positive and negative? This last one, I'm just going to make a little bit more space. The last one's a little bit more interesting because we've got a turning up twice. My plan of attack is to get all the a's to this side and all the not a's, other, over to the side. So I'm going to minus AC. So I've got 14a plus 6w minus AC equals 8w. Okay, now I'm going to minus 6w. And I really do apologize for handwriting in space, but I am trying my best. 14a minus AC, because we got rid of that 6w. 8w take away 6w is 2w. Now, there's an a here and an a here. That means that it's a common factor. So we've got 14 minus c equals 2w. Can you see there's a common factor of a in both of these? So we factorized it out. That's the trick. This is as hard as they get. Okay, they might put a little bit more confusing terms, but in essence, the hardest that they get is bringing all your stuff to one side, then factorizing out the thing you want to make the subject of, and then divide by that factor. So a equals 2w over 14 minus c. Okay, I don't envisage them getting any harder than that in the NCEA exam. In fact, there's some level 2 students that are still using this, well, not still using, are still struggling but on this strategy, but they find that it is one they need to practice because it turns up a lot. So going through and factorizing and then dividing by that factor is a brilliant strategy. I just want to add in one more thought, and I'll do it in a different color, and I won't make it a too complicated question. If I wanted to make x the subject of this formula, you take the cube root of y. Because it's an odd power, the only way to make an odd power, even times even times even, gives me even. Negative times negative times negative gives me negative. It's irrelevant, plus or minus. There's actually not a plus or minus. If x is positive, y must be positive. If y is negative, x must be negative as well. So it's only when you've got ones that have got even powers that you need to say plus or minus. Okay, but go through these three, especially that last one if you want the extension, and that'll really help you with the tasks for today. All right, nā mihi, everyone. Look after yourselves, and I'm sure you are being brilliant.